Okay, this is just a little video to explain about graphs and inequalities for MYP3. So going straight into the iMaths exercise, question 1 I've got on the grid below, draw the graph of x plus 2y equals 6. Now one way I could approach this is to rearrange it as y equals something x and something else. So rearranging that, 2y equals minus x plus 6 and y equals minus a half x plus 3. So that would be a line that cuts at 3 and has a gradient of minus a half. So for every 1 across, it's going to go down by a half. 1 across, down by a half. So like that. And it says your line will turn blue when you've plotted it correctly, which it just has done, so that's good. Another sneaky, not sneaky, but clever way to approach these types where you have the x and the y on the same side, instead of rearranging them, think about what happens when x and y are 0. So if that x was 0, you'd just have 2y equals 6, which would mean y would have to be 3 to balance it. So when x is 0, y has to be 3, which means it goes through the point 0, 3, right there. Similarly, if y was 0, then you just have x equal to 6, so x would have to be 6 to balance the equation. So when y equals 0, x has to be 6, so it goes through the point 6, 0, x equals 6, y equals 0. So when you have the x and the y on the same side, you can figure out what the graph looks like. Instead of rearranging it into y equals mx plus c, you can figure out the 2 points where it's going to cut the axes and then just join them up. So it says click to shade the region for which x plus 2y is less than 6. Well, bearing in mind that we just said that everywhere on the blue line x plus 2y is equal to 6, everywhere above the line x plus 2y must be greater than 6, and everywhere below the line x plus 2y must be less than 6. And you can figure out which side is the right side for that by considering a specific value. So for example, at the point 1, 1, you've got x equals 1 and y equals 1. So if x is 1 and y equals 1, then x plus 2y is going to be 1 plus 2, which is 3, and 3 is less than 6. So it's the region under the line where x plus 2y is less than 6. So let's just click that, and it's shaded. So we're going to mark that, and that's correct. Going on to question 2. So it says, write down 3 inequalities satisfied by all the points in the unshaded region. So what's going on here? You've got 3 straight lines, and they cut the coordinate axes into different regions. So you've got to think about the equations of these straight lines and whether you're above or below them, and what would leave you with the shaded region. Okay, so let's look at the first one. It just says x. Well, if I look at this vertical straight line, vertical and straight lines have special types of equations. They don't follow the y equals mx plus c pattern, because, for example, a vertical line has infinite gradient and a horizontal line just has 0 gradient. So a vertical line is infinitely steep and a horizontal line isn't steep at all. So a vertical line, on this particular vertical line, the x value is always 4. So it's defined by the equation x equals 4. Y doesn't come into it because whatever the y value, x is always equal to 4. the equation of that vertical line is x equals 4. Okay, so the equation of the line would be x equal to 4, but we want the region that contains the unshaded area, and that would be x less than 4. So let's just see if we can type in a less than symbol. There we are. Okay, so in a similar way, horizontal lines have equations that are defined by y equals something. So on this horizontal line, the y value is always 8. It doesn't matter what the x value is, the y value is always 8. So that horizontal line is defined by the equation y equals 8. So if on the straight line y equals 8, always, irrespective of x, then under the straight line, which contains the unshaded region that we want, y is always less than 8. So the inequality that contains the region we want is y less than 8, like that. So looking at this last one, well, it would be helpful to figure out the equation of that line. So it's got a gradient of -2, because for every 1 across it's going down by 2, and it cuts at 8. So the equation of that line must be y equals -2x plus 8. Let's just go into Word for a minute. Okay, so we figured out that the equation of that line could be written as y equals -2x plus 8, but from the list of equations on MyIMaths, they had the x and the y on the same side. So let's just rearrange this a little bit so that the x and the y are on the same side. I'm going to add 2x to both sides. So if I add 2x to both sides, I'll get y plus 2x equals 8. Let's just put some spacing in there to make it clearer what's going on. So there we go, everything nicely lined up. Keeps putting dots in for some reason on Word. Okay, so we started with y equals -2x plus 8. We added 2x to both sides to get rid of -2x on the right hand side, and then we end up with y plus 2x on the left hand side because we added 2x to both sides, equal to, then there's still an 8 on the right hand side. I'll just swap those two around a bit. So instead of let's just do it in another line. So copy that and paste it, and all I'm doing now is swapping around the 2x and the y so that it looks exactly like the one on MyIMaths. So the equation of that straight line on the MyIMaths was 2x plus y equals 8. Okay, so we figured out that 2x plus y equals 8 is the equation of that straight line, but we want the region above it because it contains the unshaded bit. So everywhere above the line, 2x plus y is greater than 8. So let's just type in a greater than symbol, and then we're left with a region that is below the x equals 4 line, or to the left of, I mean by below the y equals 8 line, y less than 8, and above the 2x plus y equals to 8 line, 2x plus y greater than 8. The unshaded region satisfies all of those inequalities, and the bits that have been shaded off are the bits that don't satisfy all of those inequalities. So the region we're left with satisfies all three inequalities. Let's mark it, and we seem to have got them all right.